here you're given the function phi of xyz is equal to x squared y z cube, and a is equal to xzi minus y squared j plus 2x squared y k. You must find the grad of phi and the curl of a. Write it down, pause the video, and work them out. Okay, good. So you've done that and you're finished. Now, notice you're asked to find the grad of the scalar. Alright? Because when you find the grad of a function, it's a scalar function. You find the curl of a vector function. When you find the grad of a scalar, you get a vector. You wouldn't really be able to find the grad of a vector. You find the grad of a scalar. And then the divergence and the curl, even though we're not asked for divergence here, the divergence and the curl, you find those for a vector, right? And you get a vector. Now, the grad of phi, right? Sometimes written as nabla, phi. Well, remember, grad is a gradient, and the gradient function, you get it by differentiating, right? So you're going to differentiate partial derivative with respect to x, partial by partial x of phi in the I direction plus partial by partial y of phi in the j direction plus partial by partial z of phi in the k direction. So the grad of phi, alright? When you differentiate this with respect to x, you're going to get 2x yz cubed in the I direction plus differentiate it with respect to y now, you're going to get x squared z cubed in the j direction plus and partial, the partial by partial z is going to be 3x squared y z squared in the k direction. So you see that if you're asked for it at a certain point, you would substitute the first value for x, the second value for y, and the third value for z. Right? If you're asked for it, given the coordinates of at a certain point. Alright, so that's the grad. Now we need to find the curl. Now here, the curl is the cross product of the grad and of the gradient, not the gradient of a now, just the gradient and a. Okay, so what you're going to have, the gradient, just grad, is going to be partial by partial x in the I direction plus partial by partial y in the j direction plus partial by partial z in the k direction. You have that cross xzi minus y squared j plus 2x squared y k. Okay. Now you remember how to find the cross product. is going to be a determinant, a 3 by 3 determinant, or second order determinant. In row 1, you have the directions I, J, and K. In row 2, you have the coefficients in the directions, the coefficients of the vector on your left. In this case, is partial by partial x, partial by partial y, partial by partial z. And then in row 3, you have the coordinates of the directions for the vector on the right. So it's x, z, negative y squared, 2x squared, y. Okay, so you see that. Now the next thing is to work, out what the determinant is. So therefore, nabla cross A is equal to, here you have I, and when you cover the rows and column with I, you find the determinant of what you can still see. That's delta by delta y, delta by delta z, negative y squared, 2x squared, y. Alright? Then you remember your place signs is plus, then minus, and then you have j, and you cover the row and column with j, and what is uncovered are delta by delta x, delta by delta z, xz, 2x squared y, plus k now. So that's going to be times, we'll draw it nearer, the 2 by 2 determinant. This time you cover the rows and column with k, and what you see uncovered would be delta by delta x, delta by delta y, xz, and negative y squared. Alright. Now that means del cross A, or nabla cross A, sometimes they call it nabla, sometimes it's called del. What you get is I, and remember your AD minus BC with 2 by 2 determinants, delta by delta y of 2x squared y minus delta by delta z of negative y squared. Alright, so you have that. Minus j time delta by delta x of 2x squared y minus delta by delta z of x z plus k, then delta by delta x of negative y squared, right, minus delta by delta y of x z. You can simplify this somewhat and say therefore nabla cross A, the cross product, the curl of the vector A, alright, is equal to I and partial by partial y of 2x squared y minus, well, it's minus negative, right? So you're going to end up with a plus delta by delta z of y squared minus j delta by delta x of 2x squared y, right? Why am I bothering to rewrite it? Let's just work it out. So now block cross A is equal to I. When you differentiate this, you get 2x squared minus negative going to be a plus, and then, well, when you differentiate this here, you get 0 because there's no z there, alright? Minus j, differentiate it with respect to x, you get 2 2's 4 xy minus, when you differentiate this with respect to z, you get x, good, plus k. What happens out here now? You differentiate this with respect to y, but there's no y there, so that's 0, minus, differentiate this with respect to, differentiate this with respect to x, there's no x there, it's just negative y squared. When you differentiate this part with respect to y, you see that there's no y there, so this is also 0. So what you get here is this is equal to 2x squared I minus 4x y minus x j. That's it, because it's 0 that multiplies the k, so that's what you have there.